Today, have it started. So today we're going to be doing our seventh class of Java Level 2. We're going to continue our discussion that we started last week, which was about Java classes. So we talked about things like fields and methods, um, how to write a basic class, um, and today we're going to continue with basically some more features that you can do with classes. And we're going to start talking about something called inheritance, which is a way of relating classes to each other. So um, just going to jump straight into it. Um, Last week's homework was basically creating a class of your own. It was very open-ended, so everyone had different things, which is great. Um, but because of that, there isn't really like one solution that I can share with you guys. But instead, I'm just gonna do like a review of what we talked about last week, just what does a basic class look like, and we're just gonna work on from there. Um, I guess if there are any questions about classes that people have now after maybe hopefully you've played around with them, I'd be happy to answer them now, but also I can take questions after we do the little bit of review. Cool. No problem. We will go over how to write classes um, in about 30 seconds. I'm just starting up my Eclipse right now. Um, I will also show you guys today kind of another way of writing classes in the sense that before we said that each file is its own class and we only had a single class in each file, Java file. Um, but there's actually ways of putting multiple classes inside of a single file, which sometimes is useful, especially like when we're just playing around with things right now. We can keep it contained. Um, but yeah, we will see that. All right. So let me share my screen. All right. So, okay, I think it's loaded now. So let's just start from the beginning. Um, I have my example from last class where we played around with classes, but let's just start and make a completely new one. So we start with basically what we've always done before. So we do like new and class right here, very conveniently. Create a Java class. So we give it a name. Today I'm going to give it um, the automobile class, and this will be useful for the slides for today as well. And I'm just gonna leave everything default. I don't need to select anything. And it generates a very bare bones kind of file for you. There's really nothing in here. But really, this is all you need to define a class. It's really these three words right here: public, class, and then the name of the class. In my case, it's automobile. Everything inside the curly braces is what's inside the class. Um, this defines a class, but it's not very useful initially. We need to put stuff inside of it to make it more useful, more interesting to us. Um, but for these three, again, this is the name of the class. This will always be class. That's just how you tell Java you want to create a new class. You just say class. And then this first thing, for our case, we're gonna mostly just do public. This is related to who has access, who can see this class, who can use this. Um, for this class, we want everyone to be able to see it. We want everyone to be able to use it. So we're gonna say public here. Um, we're going to see an example a little bit later about non-public uh, things, but for now, we'll leave that as public. Um, so I kind of already mentioned it before, but I said the two words. But last class, when I introduced classes, I said a class is broken up into two main components. So can anyone tell me one or both of the two components that we said make up a class? Thank you, Sophia. Yeah, attributes and methods. So another name for attributes is fields. But yeah, those are the two pieces of information. So we're gonna start with the attributes here. So these are basically just the same basic variables that we've seen before. So in an automobile, what kind of attributes would we have? Maybe we have a color, and then we have to say, okay, this color variable, what type is it going to be? It's probably going to be a string, right? Because we don't really have a better way of representing color currently. We could do something like numbers, but keep it simple for now. We might want something like the number of wheels that this automobile has, right? Because you can make automobiles that have 2 wheels, 4 wheels, 18 wheels. Um, it'd be helpful to have an attribute to describe that. So that should be an integer because it's not going to be a decimal value. And then you can call it num wheels, something like that. And then maybe I'll just add one more. I'll say like the weight of the automobile. So that might be a double. And then call it weight. All right. So these are attributes. Note that they don't necessarily have values currently. Um, they're just kind of fill in the blank, right? So all automobiles have a color, they have a number of wheels, and they have a weight, but it's going to be different for each one, right? So it's not like we're setting a value, like we're not saying color is blue right here, right? We do that when we create the automobile, not when we're defining the class. The second part of the class were the methods. So methods, these are just what we've seen before, more or less. Last class I described them as what the class does. So for now, I'm just going to write a single method. It's going to be the honk method. So here, I'm just going to say, how do we define a method? We have public static. Um, actually, we don't need static for this one. And then void, because the honk method, for me, all it's going to do is system dot out dot print line. So you can have a method like this. Actually, I'll make a tangent. You can do almost anything you want with these methods. The ones that we've seen in the past, they all take in no parameters. They are all void, but it doesn't have to be. You can do anything you want with these methods. So for example, maybe I want a method like public, still going to be void, but like change color, right? And this one, instead of taking in no parameter, it's going to take in a string, capital S, new color, something like this, right? So this method takes in a parameter, and then we can say system, or not, we don't need to print anything. We can just say color equals new color, right? So we take the field, the attribute, and we set it equal to whatever is passed into this method, right? And you can imagine you can write methods that take in multiple parameters. You can do all sorts of different types. You can have methods that have return values, maybe like public int get num wheels, right? Very, this is called a getter method because all it does is return some field value. So num wheels. Okay. So you don't have to just write methods that are void and take in no parameters. You can do whatever you want with them. So any questions at this point about writing classes? Aaron, was this a good refresher, or is there something you'd like me to go over more about writing classes? Or anyone else? Like cool, Aaron. But does anyone else have questions about what I did right here really quickly? All right. Um, so this was basically one half of the story. the other half of the story is how do we like use this class, right? Um, we had classes and we had objects. So here we defined the class. We defined in general what an automobile is. But at this point, we want to take this and create objects, automobile objects. We want to create specific ones, right? So for this, I'm going to create another file, new class. And this one, I'm going to call it class 7 because that's what today is. And here I'm going to check one so it has the main method, right? Remember, this is called the main method. It always has the signature, public, static, void, main, string, array, args. It always looks like this. And this is what's run when you hit the play button in Eclipse, right? And if you note, our automobile class doesn't have a main method. And that's fine. Not all classes need a main method. Not all classes are meant to be run. This class is not meant to be run. It's meant to just describe what an automobile is. But this one, oh, well, it's kind of cool, but I don't want that. This one is what we're going to actually run and execute in Eclipse. So, can anyone tell me what I should put here to create an automobile object? So here, so I'm looking for like, what's the line of code that I want to create an automobile object? I want to create it and store it into some variable. You can call the variable whatever you like. So I'll give you guys a moment. And when you have it, you can put into chat or something else. You can speak out as well. Um, I don't see anything in chat currently. Um, maybe I can call on someone if nothing shows up. Um, maybe Ethan, can you help me with this? I want to take the automobile class that I wrote, and I want to create a specific object of this class. And so I'm looking for what line of code do I need to do that? It's going to look something like something equals something. So looking for what this should look like. Yeah, so I have my automobile class that I just wrote, and I want to create an object. I want to create an automobile object. So I can call the methods, I can access the fields. Um, so how do I do that in Java? And the hint is sort of um, it's going to look something like this, where I have something equals something else. And these blanks could be multiple words. It's not necessarily one word. But do you remember, Ethan? It's okay if you don't. I can help out with this maybe, but then I'll ask another question later. Aaron says, does it start with automobile? Yes, it does. So um, on the left side, we would have something like automobile, and then I give it a variable name. So like, I don't know, aught, I'm just gonna call it. And then now I just need the right side, which is where we actually like create the object. Um, so here's like a variable. I'm just gonna call it A actually. So this is variable A. The type of it is it's an automobile. But where do I get the automobile?
I have a Java class. Yeah.
Then you're unmuted just in case. Okay. Um, yeah, so to actually create the automobile, you need to say new and the class name, like this, right? And this kind of line, we've seen something similar to this before we um, worked with classes. So back when we did like user input, this was the example I used last week. To create a scanner, we did something like this, right? Well, maybe something like system.in. And then I need to import it to get rid of the errors. So if you look at these two lines, they look very similar to each other, right? Um, when we're creating a scanner, this is what we've seen before. On the left side, we have a scanner variable that we called in. And then on the right side, we do this new keyword. We use new and then the class, which is scanner, and then we passed in system.in this case. For automobile, it's a little bit simpler. We don't pass in anything inside the parentheses, but the structure is exactly the same. On the left-hand side, we have a variable A, that's the type automobile. And on the right-hand side, we have the new keyword, and then we say the class name automobile, right? So this new automobile right here is what creates an object, an automobile object. But then once we create it, we need to store it into a variable so that we can work with it later on, right? So we store it into this variable A. Does this make sense to everyone? I want to make sure this is clear. Again, here we write the class. This is like a blueprint. This is a abstract thing. But here's where we make it concrete. Here's where we use that class that we wrote to create an object. And then we can now use this object to call the methods to access the variables, everything. Okay. I am going to get rid of the scanner line for now because we don't need that. But now that we have an automobile, we can do something like a.honk, right? Because we define the honk method here. And we just access it by taking our object, which is A, and then we use the dot, the period, to access the honk method, right? And because the honk method doesn't take in any parameters, like here, we defined it to take in no parameters, we don't need to pass in anything in the parentheses. If I run this, we can see it does print out honk. We can do some other things like a dot, um, what was it called? It was called change color. So we have the change color method, and we can do something like green, right? And then we can do system.out.print line. And we can do something like this because color is one of the fields or attributes of the class. So we access it just like with the methods with the dot operator, right? So here we're accessing the method color change color, and here we're accessing the field. And if we run this, you can see that it prints out green. And of course, like we can change it to a couple other colors. And you can see we have red, blue. Oh yeah, I scrolled. It didn't show up, but we have green, red, and blue. So we set it to green, we set it to red, and then we set it to blue. So really quick question, but something that we did talk very briefly about that in the class last week. If I create another automobile object, right? So I create another automobile just the same way as I did the previous. Oh, very quickly. Okay, sorry. Something disappeared from me. Um, if we create another automobile object, we can now use A2 to access the same stuff again, right? So we can do A.honk, but we can also do A2.honk, right? And so maybe we do A.change color green. We also do A2.change color green. And so I'm going to print out A.color and we print out A2.color. So here we run this. We can see now we have two honks because I do A honk and A2 honk. And then we see that both of them are in green. So if I do now A.change color blue, and now I print out the colors again, right? Let me print out like a divider. Can anyone tell me what am I going to see here? What is going to be printed out at this point? Is it going to be green, green? Is it going to be blue, blue? Or is one green and the other blue? Sophia says blue, green. Does anyone else want to back her up or give a different answer? Okay, yeah. Seems like Angela, Stephanie, y'all agree. And that's good because if we run this, we do indeed see blue, green. And this is again just showing that these fields, right? We define our fields up here. We only define string color once, but every single copy of the automobile class has its own, every single object of the automobile class has its own version of it, its own copy. So that means that if we do A.change color, A's color will indeed change, but A2's color will stay the same. It's unaffected. Um, maybe just a fun fact. We'll see what this does more later. But if I add one word to this, we're going to see something weird. So here's a word that we've seen before, static, right? For example, we see it right here, right? Public static void main. If I just insert this word static in front of string color, and I run this file again, we're going to see something interesting, right? Both are green. That makes sense because we set color green. But then now when I print out A color and A2 color, see both are blue. So what does this tell us? Or what can we guess from this? The static keyword means that instead of each object having its own copy, now they all share the same one. So static, one way you can think of it is it means that there's only one version for the whole class. So there's only one color field for the whole automobile class, and all objects of the class share that one field. If you modify the field from one object, the other object, any other objects will also have the same change. Obviously, in our case, we don't want this to be static. We want every single object to have its own copy. But there might be cases where you want some shared values across all your objects. And in that case, you would do static. One way I think about it, static, pretty much what I just said here. Static just means one for the class. It's like static and classes are related to each other. And that's why when I told you guys how to write methods before, like I said, everything is just going to be public and static. That's kind of why I didn't talk about it then, because you really need to understand classes to understand how static works. But that's a bit of a tangent, and we might go into this a little bit more later. But yeah, that's a one cool thing that we can start seeing already. So what does the static word mean? Again, with static, if I change A's color to blue, both of them change. If I don't have static, which we probably want in this case, like we probably don't want static, is what I'm saying, then we get blue-green. So hopefully everyone sees the difference there. Without static, every object has its own copy. So this is pretty much where we left off. And now we're ready to talk about new stuff. But before that, any questions about what I've gone over so far? Yeah. I'm purposefully spending a long time reviewing because classes are a difficult topic. It really does take just time to get used to them. And practicing writing classes on your own is a really good way of building your knowledge as well. I don't see much, so I'm going to start to pull up the slides. But if anything does come up, again, please feel free to put it into chat. Right. Right. So here, I've pulled up the slides. Hopefully you see them now. The first thing I want to talk about is what we didn't get to last week. And that's something called the constructor. I noticed that in a lot of your guys' homeworks that some of you guys actually wrote constructors for your classes, which was not required, but very good. Maybe you already knew it before, or maybe you just looked ahead in the slides and you saw it, but we're gonna go over it together right now. So constructors are what's used to create objects of a class. So we've been using constructors without really writing them ourselves so far. So if we look at our code, where are we using constructors? We're using it when we say this new keyword, right? We say new, and then this is a constructor. This is called the default constructor because it's kind of plain and simple. It doesn't take in any parameters. It doesn't really do anything interesting. It's the default. And it's also the default because it's given to you. You don't have to write the default constructor. But we're going to see what happens if we want our own custom constructors. We can do that. One special thing about the constructor that's different from other methods that we've seen before is that the name of the constructor is very special. The name of the constructor must match the name of the class. That's how Java knows it's a constructor, right? So we don't have freedom in this case. We don't have freedom in what we want to call the constructor. It has to be the name of the class. So the slides we've kind of talked about already. So I'm going to jump to the code and show off how to write a constructor. And then we'll go back to the slides after that. So I'm going to put the constructor in the methods section. And by the way, I'll maybe, just in case you want this, I'll put the code into chat and you can copy this. Oh, I did this again. I don't know what keeps happening. Not the best to copy and paste, but I have the automobile class and the thing that I run for as well. But here, I want to write my constructor. So I'm going to put a comment. Right. So constructor. Well, just like the other methods, it's going to be public. Would be, yeah. Actually, how do I describe this? The other thing about the constructor that's a little bit different is that you don't have to say a specific return value, right? In a way, you can think of the constructor as returning an automobile, right? Because that's what the constructor does. It creates an automobile and returns it. But you don't have to specifically say the return type here. You don't even have to say void. You just go straight to the name. So public automobile, right? And maybe I can do like a system.out.println, making an automobile, right? So here I have a no argument constructor, nothing's passed in, and all it does is print out this line, right? If we go back to our original file, this class 7, we can actually run this and we'll see something different now. Right. We can run this file. And if I pop this up a little bit, you can see our line shows up, making an automobile, making an automobile. That's because when we do this new automobile right here, we're calling the constructor. This line right here, new automobile, calls this method. We can create another, sorry, the highlighting is a bit weird. We can create another constructor, but this time let's make one that takes in a color, a num wheels, and a weight. So like string C, int NW, and then double W. So here is a constructor that takes in 3 values. And then I'll change it to saying other constructor. Other constructor. So now what I can do is I can set our field values to whatever is being passed in. So we can say color equals C, num wheels equals NW, and then weight equals W. Right. Note how this looks. Let me make the code bigger again. On the left-hand side, we have our fields, color, num wheels, and weight. On the right-hand side, we have whatever is passed into our constructor. And this should make sense because the left-hand side is where we're storing the value. We want to store it inside our fields, inside of our attributes. So that's why it's on the left. If you did it the other way around, it would compile, it would run, but it wouldn't do what you wanted. So if we save this, save it, and then we run our file again, nothing changes. Nothing changes at all. I don't care about this. This still says making an automobile. It doesn't print out this line, other constructor. And that's because we're still using the default constructor here. Maybe for A2, instead of using the default constructor, I'm going to use the new one that we just wrote. So that one, if we look back, takes in a string, an int, and a double. Right. So let's do that. Maybe this is gonna be pink is the string, the int is gonna be 4, and then the double is gonna be, I don't know, 2000. Right? And if I run the file now, you can see the first time we created an automobile, it just prints the basic one. It prints the one in this version of the constructor. Right. The second time that we make an automobile, it prints out the other line. And that's because we're using a different constructor than before. This is useful because now, let me just maybe comment out this here. We can now do something like etude system.out out.println a2.color. And you can see that, oh, cancel. Something's wrong. Oh, yeah. I don't need this line. Please save and run. You can see it immediately is already pink. And that's because it was set by the constructor. A really quick question for you guys. What is this called when we have two methods that have the same signature but different parameter lists? We had a term for this in a previous class when we talked about methods. Awesome. That was fast. Yeah, thank you, Sophia, Angela, Jerry. Yep, this is called method overloading. So when you write multiple constructors, you're really just overloading the constructor. You're making different versions of it. Here we have one that takes nothing. Here's something we take 3. You can write one that maybe only takes in a color and then set some values for wheels and wheat initially. That's pretty much all I wanted to talk about. There is one thing you have to watch out for, though. Maybe I'll mention that. So say I comment out this, right? I comment out my default constructor, but I still keep my this version, the 3 argument, the string int double constructor. You might see something interesting. If I go back to this file where I'm running everything, you'll notice that my code has an error, right? It's saying there's an error with this line. Specifically, it says the constructor automobile with no arguments is undefined. And you might think, well, this is a little bit weird. It's the default constructor. Shouldn't it be given to me automatically? Well, it's only given to you automatically if you don't define any constructors yourself. So the moment that you define your own constructor, Java says, okay, you already have a constructor. I'm not going to give you the default no argument one automatically anymore, right? I don't need to give it to you. You already have a constructor. And so this is why it's saying it doesn't know what this is anymore. So whenever you write your own constructors, you have to start defining your own default constructor, right? So we actually have to have this here, or else our code will not run, right? So if I put that back in, I have to save it. But once I save it, now the red underline goes away because the default constructor is back. Right. Cool. Any questions about constructors? You can have as many constructors as you'd like, as long as they have different signatures, of course. You can't have 2 constructors that have the same signature. It's just like any other method in that case. All right, so that wraps up the basic class discussion. And we have about 20 minutes left. And I want to use that to talk about a new concept afterwards called inheritance. Let me jump to the street. Yep. So inheritance in Java, it's really a thing in programming in general. So you'll hear this term inheritance. And it's a very popular, or it's a very like well-known and important concept to understand. But the name inheritance is there for a reason. It models real life inheritance, right? So maybe you've taken a biology class or have heard about things like, your parents have certain traits and they might pass that down to you, right? If your parents have blue eyes, maybe you're more likely to have blue eyes as well, right? Because something from your parents is passed down to the child. That same idea applies in computer science. We're going to see that we have things that are like parent classes and we have child classes. Another term for that is superclass and subclass. There's a lot of actually terms for it, but those are the ones that I'm going to be using the most. Parent and child, or super and sub. So super means above, it means the parent, and sub means below is the child. And the way we say this is that the child inherits from the parent, or the subclass inherits from the superclass. What are we inheriting? We're inheriting all attributes and methods. Actually, I say all, but we're going to see that's a bit of a caveat. Not all, but most. We're going to be inheriting attributes and methods. So this side goes into how we're actually going to be representing the inheritance in Java. But I think at this point, we're going to just straight go back into the code. So here I have the automobile class, and the automobile class is a good candidate to show inheritance. Right? So we have all the stuff here, and I'm going to write another class in this file. I told you guys that I'd show you how to do this. So you can have two classes in a file by just, well, first, here's public class automobile. It ends right here on line 32. I'm going to go below that, and I'm just going to say class car, right? Yeah. So here I've defined a car class. Notice it doesn't have public. This is a thing with multiple classes in a file. Only one of them can be public. The rest don't have public. And the one that is public needs to be the same as the file name. So automobile here has to be the same as the file name, automobile. But you can have multiple classes defined. You just don't put public. And this one doesn't have to match the file name because it's not the public one. But here, right now, this is just like a class that we've seen before. It's not doing any inheritance. How do we do that? It's actually in this first line here where we define the class. We type extends and then the parent class. So here it's going to be automobile. Right. So class car extends automobile. The biggest one gets public. Technically, it doesn't matter. In this case, yes, the parent class is the public class. For our purposes, we could have made the car class public as well and called this file car.java. The whatever class is public needs to match the file name, right? So if I, for example, move the public to car, it's going to complain. It's going to complain because it says public type car must be defined in its own file. And that's because it's expecting automobile here, right? Because it's called automobile.java. But yeah, if we change the file name, it would have been fine. It wouldn't have complained. Yeah. Usually you're gonna put multiple classes in their own separate files, but here's just a shortcut. I don't want to make a separate file. But everything would be the same if I just created another file called car.java. But yeah, this is the key. Right here, extends automobile. And at this point, we actually have something interesting already. If we go back to the class that we're running everything, I'm going to comment out everything I've done before. And here, I'm going to create a car object. So I'm going to ask this again. We already have a template on the screen, but can someone give me a line of code to create a car object? I don't want to create an automobile. I want to create a car object that we defined right here, class car. So what is the line of code that I need to create a car object? Again, it's going to be something like this equals this. So Tyson says car name equals new car, and you're exactly right. Sophia did another one, car Toyota equals new car. Yep, that works. car, and then your variable name. Here I'm just gonna do C because I'm lazy with names. Um, and then you guys are both right. New car and parentheses. So what's really cool about inheritance is that, well, it gets all the methods and fields that the parent class has. And we already defined a lot of stuff for the automobile class. We defined color, num wheels, weight. We defined two constructors. We defined honk, change color, num wheels. We can use all of those right now already with our car object. We can do C dot honk, right? And if we run this, so we can see it actually does two things. It called the constructor new car. And what did that do? It actually called the automobile constructor, making an automobile. And it also said honk, right? It said honk because it knows what honk is, right? This is really the power of inheritance right here already. No, look, we didn't write anything really to define the car class. We just said car extends automobile, and boom, you have access to everything that automobile class has. This gets into the fact that don't reuse code, right? Um, we write the code once, we bundle it inside the automobile class, and if we want access to this for other classes, we just say extends, and we extend automobile, boom, we have it. Is it like function, dot function? Is it like a function? Is what like a function? Is extends like a function or um not sure your question. Inherit. Um it so inherit is an idea. So when we say car extends automobile, what this does is it takes everything that's in the automobile class and basically just puts it into the car class for us. So it's effectively the same thing as if we just like took this sort of stuff and just pasted it into here. But the power is we don't have to paste it. Right? We don't have to copy paste. It's done for us. And the reason why this is useful is because, well, imagine we have multiple classes that extend automobile and we want to change what honk is, right? Maybe we want to, I was like, oh, we want a capital H. It looks better that way. We just change it once in automobile, and everyone that in extended automobile will have that update. Um, the reason why it works is because we have this extends automobile two words right here. Does that answer your question, Jerry, or is there something else that you're trying to ask? Because I might not. Um, yeah. You're right. That's exactly how it works. Yeah. Basically, whatever is after extends, you just get all that sort of stuff over. It comes over to you. Yeah. Um, working on time, looking good. But that's not all inheritance lets you do. Um, what do I want to do next? Okay. So we saw with constructors something called overloading. It's called overloading because you have essentially multiple versions um, of the same method. Another concept in programming that sounds very similar, but is means something else. And that concept is called overriding. So you can override methods. And it's pretty much what it sounds like. Here, this car class inherits this constructor. It inherits this honk method. Those are the ones I'm going to focus on. But I can write my own versions of the honk method in the car class that does something different, and it will override the one that I inherited. So I'm just going to do the honk. So public void honk. So I need to make it look exactly the same as the original one. So here is public void honk. I need public void honk again. No, this is different from overloading. Overloading, you have is something like this, where it's not exactly the same. You have a different parameter list, right? Here you have nothing, here you have three things. Overriding, on the other hand, it looks exactly the same, except they're in different classes, right? So here's the honk method in the car class. Here's the honk method in the automobile class. The signature, the first line, looks identical, and it needs to be identical to be overriding. But maybe instead of just saying honk, I'm going to say car goes honk, right? And I close it. So I define a new honk in the car class. And if I run the exact same code that I had before, where I create a car and I do honk, boom, look at the difference, right? Instead of honk now, it says car goes honk. So this worked because we overrode the method that we inherited. Again, if I just like pretend I got rid of this, the car class already has a honk method. It has it because automobile had a honk method, and we extend automobile. So we get the automobile's honk method. But at this point, we say, okay, yeah, we inherited this method, but we want it to do something slightly different. We don't want to do the same honk that an automobile does. We want a different honk for a car. And so we write our own version here. And this overrides the honk method. It says, okay, I inherited one from the automobile, but I don't care about it anymore. I have my new, more specific version here. I have the one for cars, which is more specific. And so instead of using the one I inherited, I'm going to use this one, the new one. And so when I call c.honk, it says car goes honk, right? If I like take this line back, I create C and I create A, you'll see that we see honk and car goes honk, right? So here, you can see that there's two versions of honk, one for automobile and one for a car. Does this idea of method overriding make sense to people? It sounds similar, and in some ways it is similar to overloading, but hopefully you can see it's also a very different kind of idea and used in a different context. They're both very useful. You will see them a lot, but they're definitely different things. Here, we take the method that we inherited and we write a new version of it. We could also override any of the other methods that we've inherited. But overriding only happens after we inherit something, or after we inherit something. Right. Cool. In the last 5 minutes or so, I'm going to introduce another big, important concept in programming in general. We're probably going to review it next class as well, but I want to introduce it because it's also going to be on the homework. But it's really not a scary idea. And it's actually basically what we've already seen before. So I'm going to take the code that we have and I'm going to modify it slightly. Instead of car C, you can do automobile C. So this is fine for Java. You can, if you think about how cars and automobiles are related with how we defined it, automobile is the superclass. It's the general class. It's the parent. The car is the subclass, the child class, and it's a more specific version of the automobile. It's kind of like rectangles and squares, right? Our superclass is the rectangle. Rectangles cover a lot of things, but a specific kind of rectangle is called the square, right? It's a subclass of rectangle. In Java, when we create objects, like how we did here, we can store this car object into an automobile variable. Instead of even to make it hopefully less confusing, I'm going to change it from C to A2. Right? So we create A1 and we create A2. They're both automobiles. Right? Except the second automobile is actually a car in disguise. Right? It is an automobile, but it's a specific kind of automobile that behaves a little bit differently than, say, a general one. Right? What you can't do is the opposite. You can't do this, right? So really quickly, you can't take an automobile and stick it into a car variable. So that's because, again, automobile is a general class and car is a specific. So you can put a specific thing into a general variable, but you can't put a general object into a specific variable. Again, I encourage you to take some time to think about this, like squares and rectangles. I'm sure you've heard a lot of times. All squares are rectangles, but not all rectangles are squares. In our case, all cars are automobiles, right? If you're a car, you're an automobile, right? Because car extends automobile. So if you're a car, you're automatically an automobile. But if you're an automobile, that does not mean that you're a car. You could be a car. Some automobiles are cars, but some automobiles could be something else. Maybe we have a truck class. Maybe we have a motorcycle class, right? Those are all automobiles, but they're not cars, right? So this is the first thing that we have to understand for polymorphism, which is the topic that I'm going to introduce. But hopefully that was clear why we can say automobile here, even though we're creating a car object. But the actual polymorphism part, the big scary term, is actually what we've already seen. We can do A1.honk and A2.honk, and we can see that they do different things. For now, I'm just going to get rid of this print statement because I don't want it distracting from what we're supposed to look at. So here you can see A1.honk does honk, and A2.honk says car.honk, right? And from what we understand, this should not be too surprising because, again, A1 under the hood is just an automobile class. It does the normal honk. A2, though, under the hood, it's a car. And we said cars do this specific different honk. So it just shouldn't be too surprising that we get different outputs here. But the reason why this is interesting is because let's do something like this. I'm going to make a method, and then it says like make honk, and it takes in an automobile, right? And all it does is a dot, right? It takes an automobile, and it calls honk on it, right? At this point, if we're looking at this sort of code, we can guess what would happen here, right? We can guess that this is going to be something different. But if we change this to make honk A1, make honk A2, and I run this, it's going to do the same output as before. But if we now look only at this bit of code, imagine we didn't have access to anything else. This bit of code can do different things depending on what A is, whether A is a car or whether it's a general automobile. If we had more time, we could make other classes, like a motorcycle class, a tractor trailer class, a SUV class, right? We could have all these different classes, and they could all have different honks. And this method would all do different things depending on what A is. But if we only saw this method, we would have like no idea. Like we don't know what A is specifically. All we know is that it's an automobile of some sort. And that is the concept of polymorphism. We're going to talk more about it next week, probably. But for homework, what I want you guys to do is, again, something similar to what we did in class, but your own creative twist on it. You can take what you did last week, but I want you to have a parent class. I want you to have a child class that inherits from it. I want you to override a method like we did here with Honk, and then shows off some polymorphism with calling the same method but having different things show up. All right, I think I'm a minute or two over time, but hopefully all good. Thanks for sticking with me. That's all the content I had for today. Again, if you have any questions, I'll be sticking around to answer them. But if not, have a great week. Hope to see your homework solutions. I hope to see what creative things you come up with. And I'll see you all May 8th, I think.